Hello, thank you, thank you, thank you, thank you. Our sincere appreciation goes to everyone who has tried one way or the other to make our works online known to people. Our sincere appreciation goes to you, to our clients, our students. In fact, they are wonderful, wonderful students. And so supportive, sharing our videos for your views, encouraging others to catch a view. And so many people's lives have been changed. So many students have grown interested in mathematics because of these things. We really and dearly appreciate you. We love you. We love you. Quickly, should in case you have any question, you are always welcome to reach us on our number 08164869470 Nigeria contact, and you can also that number you can reach us on contact, on WhatsApp, on Telegram, and via call. You can as well reach us on 07034345789. Thank you very much. Quickly, we will treating a topic today. We're calling it number base. Number base. A number base. What is a number base? It's an aspect of mathematics that every student should be conversant with. So, what is number base? That's the first question we'll ask ourselves. A number base of a numeral system tells us about the unique or different systems, symbols, and notations it uses to represent a value. For example, the number base 2 tells us that there are only two unique notations associated with it, which are 0 and 1. The most common number base is decimal, also known as base 10. So base 10 is known as decimal. Binary, from the word bi, means 2, is known as binary. Base 10 can also be called denary. Now let's talk about conversions. The conversion to base 10 is unique. It involves multiplying each number in the question by the given base and powering the base, e.g. ABC base 2. You can see this base is the 2. This is not the base, this one is the base, the subscript is the base. To base, let's convert this to base 10. What do? All you have to do, you have ABC in base 2. When we change to base 10, pick each of them, each of the alphabets, each of the numbers you are given. Just have A, then you multiply by the base. What is the base? Their base is 2, then plus, you pick the second one, B, again times what? Times 2. You pick the third one, plus C times 2. If you have other numbers on and on and on like that, and this one starts powering the base 0, the first base you have 0, the second base 1, the next base 2. You continue like that in that order. If you have more numbers, isn't that simple? So you have your A times 2 raised to power 2, that is 4, plus B times 2 raised to power 1, that is B, times 2, then plus C times 2 raised to power 0, that is C, times, what is 2 raised to power 0? It is 1. Any number raised to power 0 is 1, except 0 raised to power 0. 0 raised to power 0 is undefined. But any other number raised to power 0 is 1. Note that. So you have 8 and 4, that will be 4A. 4A plus, here you'll be having 2B. Then plus C. What do you have? This is what you will have as your final answer. Now let's deal with numbers. Look at these numbers that we have. We have a set of numbers. look at the set of numbers we are. Let's treat an example. Change it to base 10, conversion to base 10. Oh, so sorry about that. You have this. Look at this number. You have example, convert the following to base 10. You have 1268 base 10. What do? 1268. You have 1, 2, 6, 8. Should be is in base what? It should be in base. It can be in base. Can be in base. Okay, the question is even in base. Oh, sorry, I made a mistake there. 1264. 1264. Set is in base 8. When it changes to base 10, what do? Like I said before, the first number times the base plus the second number times the base, then plus the next number, which is 6, times the base plus the next number times the base. What do you do next? Power the base from 0. First base 0, the next base 1, the next base 2, the next base 3. So what do you have? 1 times 8 raised to the power 3. 8 raised to the power 3 is 8 times 8 times 8. And what would that give us? That would give us 512. We have 1 times 5, 1, 2, plus 2 times 8 raised to the power 2. That would be 2 times, what is 8 raised to the power 2? 8 times 8. That is 64. Then you have plus 6 times 8 raised to the power 1. That will be 6 times 8. 8 raised to the power 1 is 8. Then plus 4 times 8 raised to the power 0. That's 1. So what do you have here? This will become what? 5, 1, 2 plus 2 times 64. That will give us 1, 2, 8 plus 6 times 8. That will give us 48. And plus 4 times 1. That will give us 4. So everything will be equal to what? Add them all together. You're going to be having 6, 9, 2. Indicates is in base 10. That will give us our final answer. So as you can see, the conversion to base 10, it's unique. It's quite unique. It's very, 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 very unique. The conversion to base 10 is unique. And that is why any conversion you are doing to base 10, you follow this order. You follow this order. Now let's go to conversion to other bases. Conversion to other bases takes different approach compared to that applied when converting to denary. A tabular approach is used. Example, convert 50 base 10 to binary. Converting now to binary, that is base 2. I have to convert 50 and it's already in base 10. Most of the time they're always in base 10, then you can easily convert to other bases. For example, if you have a question in base 2, you are told to convert to base 3, you can make it easier for yourself by converting to base 10 first, then you come and convert to base 3. And you're going to be using this tabular approach. Let's quickly use the tabular approach, and it is the principle of remainder. So you have 50, and convert this to base 50 to base 10, and 50 in base 10, 50 in base 10 to binary. How well can you do that? or you use your what? Is a tabular approach. Move this way, draw this, have 50 here, have 50 here, you have 1 here. 1 and 2, you're combining to base 2, right? Binary, you use 2 to divide. If you're combining to base 3, you use 3 to divide. If you're combining to base 8, you use 8 to divide. But something, check here, 2 in 5, it is 2. Remainder 1. And that becomes 2 in 10, that is 5. Is there any remainder? You note your remainder is remainder 0. You come again, you divide again until you can't divide again. 2 in 2, 1. 2 in 5, that will be 2. Remainder what? Remainder, sorry, remainder what there? Have remainder 1. Then you come again, 2 here, 2 in 12 is 6, remainder 0. Check again, 2 in 6 is 3, remainder what? Remainder 0. Go again, 2 in 3, 1, remainder what? Remainder 1. Then you go again, can 2 in this 1, 2 cannot go in 1, that will be 0. Then what will be left? You have remainder 1. Then you draw an arrow, preferably to show the direction of the values that you're going to be writing. You write from down up. You are writing your remainders. The remainders are the answers. So that will be what? 1, 1, 0, 0, and 1, 0. In base what? It is in base 2. That forms your answer. If you are converting also, you want to convert, okay, for example, look at conversion of 70 in base 10 to base 5. Can you see the same approach? All you have to do is what? Draw this table. Draw the table. Have this 70 and convert to base 5. 5 and 7, 1. And so this, what is left? You have 2 left. 5 in 20, 14, 4 rather. What is left? Remainder 0. Then you check again. 5 in 14. 5 will go in 14. 5 times 2 is 5 times 3 is 15. Okay, that will be 2. Remainder 4. Check again. 5. 5 in 2, that is 0. Remainder 5 cannot go into remainder 2. So that's where you stop. The final answer, okay, this arrow, what do you have? I'm going to be having 2, 4, 0 in base 5. Can you see this? So this gives your final answer. Now quickly, okay, we'll stop this video here. Then we will be taking other conversions in our next video. But quickly, we can convert again this one. Let's convert to Bicima. Let's convert to Bicima so that we know we are done with this one. What we have to do is operations of binary conversion, operations of binary conversions. Since we have done, let's do this. We have 2, 0, 2 points. We have 2, 2, 1 to Bicima. How do you do that? We convert as if we are doing to base 10. Yeah, to base 10. It's having decimal. So when you get to this place, something will happen. What do you have? You're going to be having 2 times. The question is, what base is this question? Is in base 3. All these numbers are not up to 3. That's why any base you are operating with, all the numbers must be lower than your base. All the numbers will be lower than your base. So here you have this. You have this now. What do you do? 2 times 3 plus 0 times 3 plus 2 times 3 plus, now this ones, the whole numbers is where you go with it, and you power this one. The decimal numbers we use another approach. Power this one first. 0, 1, we have 2. Now the decimal numbers, what do? You write the first one, 2 times 3 raised to power, put minus 1. The first decimal number will carry minus 1, your base will carry minus 1 there, plus the next number is 2 times 3. 3 will carry what? Minus 2. So carry minus 2 here. Then plus 1 times 3. You carry what? You carry minus 3. So what do you have? And when we're having 2 times, that will be 2 times what? 2 times 9. 3 raised to power 2 is 9. Plus 0 times anything is already 0. Then plus 2 times 3 raised to power 0, that is 2 times 1, 2. Then plus, this one will be what? 2 times 1 over 3. 3 raised to power minus 1 means 1 over 3, plus 2 times 3 raised to power minus 2, that is 1 over 3 raised to power 2, and that is 9. Then plus 1 times 3 raised to power 3 is 1 over 2, 3 raised to power 3, that is 1 over 27. That's 3 raised to power 3, that is 27. So here will be 18 plus 0 times 2 is 0 plus 2 over 3. Then you have plus 2 over 9. And you have what? Plus 1 over 27. What do you do next? Here, you can just write it as find the LCM of everything. The LCM of everything should be 27. 18 means 18 over 1. 0 is gone. 1 in 18. 1 in 18 is 1 in 27, rather 27. Then 27 times 18. That will give you what? 486. Now 486. In fact, you may not even have to do it this way. Let's see something so that you don't have to be dealing with big values. You don't have to be dealing with big values. So let's go this way. Just deal with this one that you have already. You have 27 here. Give the whole number, which is 18. 3 here is 9. 9 times 2, 18. Then plus 9 27. 3 times 2, you have 6. Plus 27, 27. 1 times 1, 1. That will become 18 plus 18 plus 7. 18 plus 7. That's 25 plus 25 over 27. What do you have there? You can quickly find the LCM of these traits. So that so what do we have? We have 27. 1 and 27, 27, 27 times 18. 27 times 18. 486. I'll be 4, 8, 6 plus 27, 27, 1 times 25. That is 25. So our answer becomes what? 486 plus 25. And 511. 511 divided by 27. What do you have? 18.93 approximately. 18.93. 3. So that gives us our final answer. Thank you for staying with us. Do more by practicing, practice the questions. Try to practice what you've done so that you have a better understanding of everything we did. Thank you for staying with us. Thank you for subscribing. Please do subscribe. Please, it is free. And encourage others to subscribe. Share our videos. Let students have it's all over the world. Let people learn. Let them enjoy from this privilege. Thank you so much. Should in case you have any question, you can reach us. You can always reach us. Reach us. For online classes, we are available to tutor your children in mathematics, physical and online classes. Reach us on 081 64 86 94 and 70. You can reach us on WhatsApp with this. You can reach us on Telegram with this. You can call us also on the same number. Thank you very much. Till I see you again in our next video. Thank you for stopping by.